This tutorial video covers an overview of CueBillet. CueBillet is a program written for cue makers that generates G-code programs used for the machining of slotted ring billets. Specifically, it includes three functions: surfacing inlay slabs to a particular thickness, milling slabs into uniform billet strips, and machining the slots in ring billets. The program is split up into three columns. The column on the far left includes setup data of the slab or indexing fixture. The column in the middle includes what specific cut is to be taken. The column on the far right includes details on how the cut is to be performed. The menu bar across the top of the screen is used to change between the slab function, which is the default when the program is run, the strip cutting function, and the three different ring billet sizes. We will start with the slab surfacing function. The slab diagram on the left is used to tell the program which corner of the slab is associated with the known XY position. To change which corner of the slab is the reference point, hit the rotation button until the orientation is correct for your machine setup. Note the label above the diagram changes to a red font when the diagram is rotated. Anytime a setup parameter changes, the label font changes to red to let the user know unsaved setup changes have been made. Typically, the X and Y axis will be zeroed at the corner of the slab. If for some reason that is not the case, the XY coordinate can be changed to whatever matches the setup. The safe Z position is the Z position the machine will travel to at the beginning and end of the cut. The Z movement always happens first before any XY movement. This number must be greater than the top of stock position. The Z top of stock is the Z position when the bottom of the end mill is touched up on the top of the inlay slab. Typically, this is 0, but the value can be changed to any number. Now that we have changed a few of the slab setup parameters, we will go to the File menu and click on Save Defaults to save our changes to the defaults file and get rid of the red font. The center panel includes the slab dimensions and details describing the cut. The slab X and Y lengths should be set to closely correspond to the actual physical dimensions of the slab. When setting up the slab, care should be taken to align the edges of the slab so they are parallel to the machine axis. The cut depth is how deep the cut is to be taken, or how much material should be removed. Next is the cutter diameter. The larger the end mill, the fewer passes that will be needed to cut the entire slab. The last input parameter in the center panel is the step over percent. This is the percentage of the cutter diameter the machine will move over for the next pass. The default value of 75% is somewhat of an industry standard. The top right input panel describes details on how each specific cut is to be taken. For each function in CueBillet, there are a discrete number of Z roughing passes. Given our 0.125 depth of cut, if we take 3 roughing passes, each pass will remove 0.042 inches of material. Increasing the number of passes decreases the amount of material removed for each Z pass, but will result in a longer running program. The next parameter is the roughing feed rate. The default value of 40 inches per minute may be a bit fast for some machines, so we will lower that to 30. Obviously, the faster the feed rate, the faster the program will run. The next parameter is whether to take a finish Z-pass. If a good surface finish is needed, it may be desirable to take a finish Z-pass on the slab. When this is checked, our depth for each roughing pass label changes. Now, the cut will actually be 5 passes, 4 roughing passes, and a 0.005 finish pass. That is likely more than necessary. We will drop that to 3 roughing passes, which now tells us each roughing pass will be at a depth of 0.04 inches. The Take an XY finish pass option does not apply for slab cutting. If a Z finish pass is taken, we can set the finish feed rate to whatever we want. 15 sounds good. The next 3 options involve the machine travel at the beginning of each cut. If rapid to safe start is checked, the movement to the initial safe Z and XY starting point will use the rapid command. When first using CueBillet, it is recommended this remain unchecked. After some experience and confidence in using the program, it should be safe to turn this option on. Rapid to 0.1 inches over top of stock, in general, should remain unchecked. It should only take a few seconds, even at slow feed rates, to descend from the Z safe position to just over the top of the stock. Lastly, when pause at Z safe is checked, a pause command is included in the program just before the machine descends from the Z safe position to start the cut. During this pause is always a good time for the user to review the settings in CueBillet and review where the cutter is in relation to the stock. Safety first. Now that we have gone over all of the slab cutting details, we are ready to generate the program. To generate a program, click the Create GCode button. When you do this, a Windows dialog box comes up. The default type is .nc. If that file type is not compatible with your machine, you can change it by clicking the Save as Type drop-down and change the file type to All Files. Then when you change the name, you can save it as any file extension. The first time this Save File dialog comes up on your PC, it will likely default to a generic Documents folder. If you change it to a specific folder where you want to save your slab cut programs to, Windows will remember that folder, and that will be the default location next time. Once the folder and file names are set correctly, just click Save and then load that file into your controller software to run it. Let's move to the strip cutting function by clicking the Strips menu item at the top of the screen. The first two strip details are the slab dimensions. We used 5 inches and 3 inches for our imaginary slab, so we might as well enter those numbers for milling the strips. Note, when we changed those numbers, the diagram at the bottom changed. The strip diagram is very useful for showing how many strips can be cut from the slab given the set of input parameters. As the slab and strip dimensions change, the diagram updates automatically. The next parameter to go over is the perimeter buffer. This parameter shows up as the red outline in the diagram. This is simply a perimeter around the slab that is not included as usable material. Sometimes the very edges of an inlay slab may include defects, or if the slab is not quite uniform and it can't be aligned perfectly with both the X and Y axes, the perimeter buffer can be used to prevent the edges from being included. The next two parameters are the dimensions of the strips themselves. In this example, our inlay slab can yield 33 strips that are 1.5 inches long and 0.2 inches wide with a 1/16 inch cutter. The white lines in the diagram are cut lines. The blue section inside the red perimeter are the remaining strips. We may want fewer but longer strips, so let's increase the strip X length to 2.4. At 2.4 inches, there are 2 columns, yielding 22 strips. There is a little material left over on the far right edge. We could probably fiddle with the strip X length to get them slightly longer to use up more material, but that is close enough for this video. The entered cut depth is 0.125. That matches the imaginary slab we just surfaced, so we won't change that. Last is the cutter diameter. Decreasing the cutter diameter, obviously, will increase the number of strips we can get. If we change the cutter to a 1/32 cutter, we would get 24 strips. That size cutter may work well, depending on the material being cut and how fast we want to get the job done. All of the cutting parameters at the top right we discussed for slabs work the same way for strip cutting, but we now can check to take an XY finish pass. If the width of the strip being milled will be the height of the strip in the billet slot, taking an XY finish cut is unnecessary. However, if the width of the strip will correspond to the width of the slot, it may be desirable to take an XY finish cut. Whether this is necessary will vary based on the cutter size and what type of material is being machined due to cutter deflection during the roughing passes. When cutting strips during roughing passes, a simple grid is cut using a series of back and forth cuts in one axis, then another series in the other axis to form rows and columns. This results in cuts being taken both conventional and climb milling. When a finished XY pass is taken, the perimeter of each individual strip is cut during the very last Z pass using climb milling for the top left and bottom right corner orientations and conventional milling for the other two. Finally, time to look at cutting slots in the ring billet. There are 3 different billet input screens, one for joint size, one for A joint size, and one for butt size. They all work the same way but have their own sets of parameters that can be saved so each one can match your default choices for different size ring billets. We will use the joint size screen during this video. The fixture setup in CueBillet is similar to the slab setup. There is a diagram with a rotation button that must match the physical setup of your fixture that holds the billet. Click the rotation button until the fixture orientation matches your fixture setup. The red dot in the diagram is the XY point that must be known for slot programs to work. That location is the indexer axis point at the very edge of the billet blank. Typically, this is where the X and Y axes would be zeroed out, but any number can be entered that matches your setup. The safe Z position, just like the slab safe Z, is the Z position the machine will travel to at the beginning and end of cut. The Z top of stock is the Z position where the bottom of the cutter is touched up on the top of the ring billet blank. CueBillet includes the option of using a 4th axis to cut all of the slots in one program. Checking this option turns on 4th axis indexing so all slots can be cut in one program. When checked, the option to skip the first index is enabled. Sometimes, even when 4th axis indexing is available, the first slot is cut by itself to test the fit of the strip in the slot. After the fit is deemed good, there may not be a need to repeat the cut for the first index position. Checking this option will skip the first index, but cut slots for all of the others. The ring diagram is a visual tool to double-check the slot width, depth, and number of slots for a visual representation of an individual ring. The current billet diameter is drawn as the dotted line in the diagram. The final ring inside and outside diameters are the solid portions of the ring. Now let's look at the slot details. Our imaginary strips were machined to be 2.4 inches long. I will set the slot to just slightly longer than that. The width is already set to 0.125, but that may need slight adjustment. Let's pretend our strips were exactly 0.125. We might initially set the slot widths to 0.126 and then do a test fit. Next is the depth. A depth of 0.150 seems to be a good number based on the diagram. If we increase the depth to 0.200, we would see that when the billet is bored, if it isn't already, the base of the material would be completely gone. We will change this back to 0.150 and leave it. Next is the number of slots. If 4th axis is not being used, this really isn't necessary, but it is still nice to use to see how the rings will look for different number of slots. Changing the number of slots changes the diagram accordingly. Note the first slot is always centered at the 0 index position. The next input is the cutter diameter. Typically, this should be large enough to cut the slot in just one perimeter roughing pass and one perimeter finish pass. If multiple roughing passes are needed to cut the entire width of the slot due to cutter size, the step over percent for slotting cutting is 45%. The next input is an option to inset the slots from the face. Some cue makers may choose to inset the slots rather than having them open-faced. When this option is checked, the slots will be inset from the face, the amount entered to the right of the option. The next two options offer the ability to cut secondary slots that either alternate between the primary slots or straddle each primary by a certain number of degrees. When either of these options are included, two G-code programs are created. One for the primary slots, one for the secondary slots. If the same exact cutter diameter is used for both sets of slots and fourth axis indexing is checked, the user will be given the option of machining all slots at the same time or creating two different fourth axis G-code programs. The cutting parameters at the top right all work the same way they work for cutting strips. The surface finish of the bottom of the slot is not critical, so taking a Z finish pass is not necessary here. However, taking an XY finish pass is beneficial for both sizing the slot and creating a nice surface finish on the sides of the slot. All passes during slot cutting use climb milling. The bottom right panel includes the ability to change from inches to millimeters and the option of turning devices on and off via machine commands in the G-code program. When the pause at Z-safe is checked, devices are not powered on until after the user continues the program. The last thing to cover is the File menu. We have already discussed the Save Defaults menu item. The next menu item is the Load Saved Cut Parameters function. When this is clicked, an Open File dialog box is displayed. This function is to load and set the specific parameters that were used to create a previously generated CueBillet G-code program. If a CueBillet program exists on the hard drive because it was created in the past, the CueBillet parameters file associated with that G-code program can be loaded into CueBillet to view the settings. Some users may wish to directly review the G-code generated by CueBillet. To do this, the user can click on the Open G-code File menu item to open a previously saved G-code program in Notepad. In addition to this, users can have all generated G-code programs automatically opened when they are created by checking the Open G-code Files When Created option. To save that setting for next time CueBillet is run, the user has to save the defaults. That concludes this tutorial video. Be sure to watch the other CueBillet videos, which include actual machining examples of the three functions described in this video.